D2DNY, Real World HVAC Simplified. And now in this video I'm going to be showing you how to measure or how to check your superheat and your subcooling. Okay, and this is going to be a very short video, 5 minutes, 8 minutes tops, I promise. But before we get into the video, before I get this video started, I want you to go ahead and subscribe if you haven't subscribed. Smash the bell icon, so when I when I upload videos like these, you get them right away. All right, so let's get into the video, showing you how to measure your subcooling and your superheat. So right now, guys, I am using the Parker Smart Service Toolkit. All right, and so for me, doing subcooling and superheat is a breeze. As you can see, I simply connect to my sensors. It's 4 sensors, and voila. So I'm gonna explain what's going on right here. So in order to measure subcooling and superheat, you're gonna need to connect your low side gauge manifold to read your suction pressure. As you can see right here, this is the blue, which indicating low side for low pressure, and I am using a pressure transducer, which transmits the pressures back to my phone through the app. It's a smart tool, right? Well, this is where you put your blue hose from your gauge manifold. If you don't have a tool like this, right, where it does it for you automatically, put your gauges right here, low side, blue hose. Then you're going to want to go on your liquid line or on your high side and connect your discharge or your red hose. As you can see, I have my red pressure transducer or transmitter on the high side. That is currently the liquid line, but if you got the compressor discharge line, same difference, you can put it over there. All right, so to recap, you need to put your blue hose for low pressure reading on the low side. That's the low side, the larger pipe, the bigger pipe, or the one that's cold or sweating. As you can see, I have my low pressure transmitter, which is the blue one right here. The blue represent low side, hooked up, and again the red for the high side. So you'll put your red hose over there, connected right there in the ports. All right, so that's that. Next thing you're gonna want to do is connect your temperature sensor on your evaporator outlet. Now in this case, this is a clamp type, as a thermistor under here, and then that transmits back to the app, right? So it's a temperature transmitter. This here's my suction line. So basically you want to put your temperature reading or your thermometer on the evaporator outlet. Now, given that these lines are insulated all the way back to your evaporator, or my evaporator that is, I can put it right here. It will be the same temperature with little to no difference. Okay. Now some of you pros are gonna object. Really, I don't care. But object if you want. So that's what it is. Suction line, evaporator temperature, or right here is fine. I said the line is insulated, so you will have the same or a little to no difference in temperature between evaporator outlet and this point right here. Now, if you don't have one of these, I'll tell you what to do later. Now, on the high side, you're going to want to have your thermistor or thermometer on the liquid line, our condenser outlet. This right here is my condenser outlet. This is currently a heat pump. As you can see, this is it right here. Liquid line is going into a TXV. And again, this is a heat pump. It's a liquid line. So condenser outlet right here. I'm clamped onto that. That's my high temperature, high temperature transmitter going back to my hap. Now, if you don't have one of these, you can get something like this right here that I have on my discharge line. Again, this is a reversing valve. This line right here is my compressor discharge, and this is also a compressor suction in the middle, and this is another suction line when it's in cooling mode, going to the indoor, and this is a true discharge pass-through going to condenser. All right, but yeah, you can get something like this, like 20 bucks, and it will work with most of your meter. The meter of a temperature scale, you can do that. You clamp this on your liquid line, clamp this on your suction line, and you can read your temperatures. Now, when you do that, though, you're going to have to calculate the superheat for yourself. Simply, you'll use your saturated refrigeration temperature based on the pressures that your gauge is reading. And then from that, you subtract the difference based on the numbers you're reading from your thermometer on the liquid line or suction line, respectively, to calculate superheat and subcooling. That's how you do that. So you get a regular pocket thermometer. You can stick it under the insulation somewhere where it's not been affected by the outdoor ambient or the ambient around it. You know, you can probably stick it onto put it on the pipe right here. It's a pocket thermometer, and then just put some insulation tape around it so that it's not being affected by the outdoor air. And then you can just use that to read the suction line temperature. Do the same thing for the liquid line. Just get your thermometer or your thermistor on there so you can read the liquid line temperature. Once you're reading the liquid line temperature, you have your gauges, the regular analog gauges hooked up, and then you can just convert the pressures to saturated temperatures, and then on the gauges, and then you know, use the temperature, those temperatures difference between what you measured on the liquid line or suction line again, respectively, to calculate superheat and subcooling. Now, I'm gonna show you right here real quick so you can see. So if you were to be using a regular gauge, so you will be reading 117 psi for R410A, as you can see here. That would be 38, that's 38 degrees. 39 degrees, just about, whatever, 39, 38, saturated temperature. And then you got 50 degrees on the suction line, as you can see, 50 degrees. So the difference between 39 currently and 50, that's 11. That's a superheat, or you know, you see it's moving around, but you get the drift. Okay, so you're going to calculate the difference between the saturated temperature in your gauges, your analog gauges. I guess, for example, currently this is at 117 psi, it's 39 degrees saturated temperature, and currently I'm reading 50 degrees on this sensor. And so that 50 degrees, the difference between 50 and 39 comes out to my superheat right there, which is 11. And you do the same thing for your subcooling. You convert the pressures to the saturated temperature. Currently this is 93 degrees for my R410A, 93 degrees, and my liquid line temperature is 90 degrees. And so the difference, obviously you can see this is very low subcooling. This system, I think, would take some more refrigerant. Even though right now the superheat looks good, has a TXV inside. I think when we have a lot more load, right now it's low load, we might need more refrigerant. So yeah, that's pretty much it, guys. Yeah, it's been 8 minutes and 38 seconds. Yeah, so that's how you check your superheat and subcooling. Simple as that. You can use something as fancy as this, or you can just use something regular, like your regular gauges, and just a clamp on thermometer like this. You know, with your meter, multimeter. If your multimeter has the temperature scale on there, you can just get something like this. Pretty much, it's just like 20 bucks on Amazon, 25 bucks on Amazon, and you can do that. Use that to measure your temperatures, or you get the pocket thermometers. But if you have the pocket thermometers, you're gonna have to insulate it so that it doesn't. Put it on the pipe right here, and then you like cover it up with some insulation tape, like something like this, so it doesn't be affected by the outdoor ambient. And that's it, guys. If you like this video, if you love it, give it a thumbs up. And if you have not subscribed, subscribe. You know, I upload videos like these on a weekly basis. All right. Pretty clean install. Oh, these wires don't be out here. Closing this video off.